NASA's Voyager 1 spacecraft engineering team is attempting to solve a puzzle. The 45-year-old spacecraft is cruising outside our solar system while maintaining contact with Earth. However, it has presented NASA's team with a mystery. So what's this secret that the team Voyager is busy identifying? Is it a serious issue? Will this be the end of Voyager 1? Let's find out. Welcome to Space Discoveries, and in today's video, we're going to take a look at the mysterious troubles that Voyager 1 is currently facing, and how NASA is handling it. Curious? Let's get into it. The Interstellar Explorer appears to be functioning normally, receiving and executing commands from Earth as well as gathering and returning science data. However, readouts from the probe's attitude articulation and control system do not accurately reflect what is going on board. The AACS is in charge of the spacecraft's orientation, among other things. It keeps Voyager 1's high-gain antenna precisely pointed at Earth, allowing it to send data back home. All indications indicate that the AACS is still operational, but the telemetry data it is returning is invalid. For example, the data may appear to be generated at random or may not reflect any possible state of the AACS. The problem has not triggered any onboard fault protection systems, which are designed to put the spacecraft into safe mode, a state in which only essential operations are performed, giving engineers time to diagnose a problem. The signal from Voyager 1 hasn't weakened either, indicating that the high-gain antenna is still oriented correctly with Earth. Strange signals from space may appear sinister, but NASA's engineers believe it is nothing out of the ordinary. The team will continue to closely monitor the signal in order to determine whether the invalid data is coming directly from the AACS or from another system involved in the production and transmission of telemetry data. The team cannot predict how long the spacecraft will be able to collect and transmit science data until the nature of the problem is better understood. Voyager 1 is currently 14.5 billion miles from Earth, and light travels that distance in 20 hours and 33 minutes. That means it takes about 2 days to send a message to Voyager 1 and receive a response, a delay that the mission team is used to. At this stage of the Voyager mission, a mystery like this is sort of a par for the course, said Suzanne Dodd, project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory in Southern California. The spacecraft are both nearly 45 years old, which is far beyond the mission planner's expectations. We're also in interstellar space, a high-radiation environment in which no spacecraft has ever flown. As a result, the engineering team faces some significant challenges, but I believe our team will find a solution to this problem with the AACS. In August-September 2017, humanity's farthest and longest-lived spacecraft, Voyager 1 and 2, celebrated 40 years of operation and exploration. Here, behind-the-scenes accounts from original and current mission team members as they describe the mission's engineering challenges and momentous scientific achievements in this panel presentation. On August 24, 2017, JPL recorded this program, NASA's Jet Propulsion Laboratory. According to Dodd, it is possible that the team will not find the source of the anomaly and will instead adapt to it. If they do find the source, they may be able to solve the problem with software changes or by utilizing one of the spacecraft's redundant hardware systems. It wouldn't be the first time the Voyager team had to rely on backup equipment. When Voyager 1's primary thrusters began to fail in 2017, engineers switched to another set of thrusters that had previously been used during the spacecraft's planetary encounters. Despite having been inactive for 37 years, those thrusters worked. Last year, space raindrops gently falling on a window were detected by Voyager 1 as a low, constant pattering against its detector. Those drops represented plasma waves, or interstellar gas, which is the spacecraft's constant companion. We're detecting the faint, persistent hum of interstellar gas, said Stella Koch-Oker, the study's lead author and a doctoral student at Cornell University. Because it is in a narrow frequency bandwidth, it is very faint and monotone. Voyager 1 could hear the monotone drone for nearly 1 billion miles, and the researchers believe these weak plasma waves are distinct from other detections made in the vast nothingness of interstellar space. For example, the sun occasionally becomes agitated and erupts, spewing particles into space. The outbursts have a distinct signature that Cornell astronomer James Cordes compares to a lightning bolt. Those bursts were once used to calculate the density of interstellar plasma, but the low, constant hum indicates that Voyager is gathering plenty of data even without the solar outbursts. Future missions to interstellar space would help clarify what's going on out there, and NASA has plans for one in the 2030s. Voyager 2, Voyager 1's twin, is still operational. Both Voyager spacecraft, launched in 1977, have operated far longer than mission planners anticipated, and are the only spacecraft to collect data in interstellar space. The data from this region has contributed to a better understanding of the heliosphere, the diffuse barrier that the Sun creates around the planets in our solar system. Each spacecraft uses about 4 watts less electrical power per year, limiting the number of systems it can run. To save power for science instruments and critical systems, the mission engineering team turned off various subsystems and heaters. Because of the diminishing power, no science instruments have been turned off yet, and the Voyager team is working to keep the 2 spacecraft operational and returning unique science beyond 2025. However, according to NASA, JPL speculation, the Voyager 1 spacecraft appears to be mysteriously confused with data due to an aurora on Mars. According to a new study, the upstream solar wind properties interacting with the crustal magnetic fields found in Mars's southern hemisphere have a strong influence on the formation and properties of the Martian discrete aurora. The physicists investigated discrete aurora, a light-in-the-sky phenomenon that occurs primarily at night in Mars's southern hemisphere. While scientists were aware of discrete auroras on Mars, which also occur on Earth, they were perplexed as to how they formed. That's because Mars lacks Earth's global magnetic field, which is a major trigger for aurora, also known as the northern and southern lights on our planet. The interaction between the solar wind, the constant jet of charged particles from the Sun, and magnetic fields generated by the crust at southern latitudes on Mars, according to the physicists, governs discrete aurora on Mars. The scientists discovered that the nature of this localized interaction between the solar wind and the crustal magnetic fields causes discrete aurora. The main finding is that the aurora occurrence rate inside the strong crustal field region is primarily determined by the orientation of the solar magnetic field, whereas the occurrence rate outside the strong crustal field region is primarily determined by the solar wind dynamic pressure. The findings are based on over 200 observations of discrete aurora on Mars by NASA's Mars Atmosphere and Volatile Evolution spacecraft. Now is a very fruitful and exciting time for Mars aurora research. The MAVEN database of discrete aurora observations is the first of its kind, allowing us to understand the basic aurora features for the first time. While the engineers work to solve the mystery presented by Voyager 1, the mission's scientists will continue to make the most of the data coming down from the spacecraft's unique vantage point. Still watching? We knew you'd love our video. Well, we'd be even happier if you could just hit that like button. Coming back to the scenario, what do we think about Voyager 1 and its mysterious glitch? Well, as Voyager 1 is far from Earth, it takes a few days to send a signal and then hear back, adding to the difficulty of determining what's going on. This leaves NASA with a lot of questions. Is the AACS to blame? Or is another system malfunctioning? Will Voyager 1 be able to carry out with its scientific mission? There are ways to get past this technical glitch. Voyager 1 may be able to live with it. A software fix or a switch to backup hardware could also be the answer. NASA hopes that both Voyagers will continue to transmit scientific data beyond 2025. And with that being said, it's time to end our video. But before that, we'd like to have your opinion about Voyager 1. Do you think the probe would live with the glitch forever? Let us know in the comments and make sure to subscribe to the channel for more amazing videos like this. And now that we know you love our videos, make sure to watch these as well. We'll see you in the next one.